Today, we're talking about algae blooms, baby. I don't know if anybody has experience with algae blooms, but I do. PFAS, yeah. I grew up on a 2-acre pond. Once in a while, we'd have that algae bloom, baby. And you got to do something about it. And, you know, when I was growing up, I thought, maybe when I'm an adult, I'd like to be algae. And then I was like, the problem is I'm just more of a fun guy. So,
Oh my god.
little extra for a shot at the hoop later, not right now. What kingdom is algae in?
Bacteria.
That was quick.
Fungi.
Good guess.
Oh, sorry.
Vinny,
Oh,
getting a science lesson today, too.
I already know. Is it bacteria?
Good guess.
Wait, what's that called? It's
Ryan.
Plant.
Most common wrong answer. That was a good guess. Troy,
Or the aquatic plant. I know
that's
it.
still a
Troy.
plant.
Cam knows it.
Cam,
Protist.
protest. Now we got a little science refresher. Here's what's happening. They need to control this algae bloom. It's bad. When algae bloom happens, it sucks a lot of oxygen out of the water system, and it'll kill some of the native plants. So, they're going to treat it. And we have this function. A, algae in square yards, equals 240 times 1/3 to the t power. Your job with your partner is to decide what is this 240 and 1/3 in context. You're going to then create a graph to represent our function and say how much will be there in 2.5 weeks. All right, I know we have a little more work to do, but let's get a couple things down. Who can tell me what the 240 means in context? What is the 240? Suzio? The starting square yards of algae, right? Okay. And then what does the 1/3 tell us, Sean?
The 1/3 tells us that that is decreasing by 2/3.
Yeah. Decreasing by 2/3 because 1/3 is left. Awesome. So we're going to use that to then graph 0, 1, 2, 3, and 4 weeks. Where's this thing start at 240, Kai? Where you got it going after 1 week?
80.
80. A third is left.
Fire.
And then week 2, how much is left, Josiah?
Like 26.
Yeah, so like a third of it. Okay. Then Ryan, how much is left after that? What? So we're at 240, a third less. A third left is 80. A third of that is 80 thirds. What's a third of that? What's next? You guys? We're at 80 thirds. I need a third of that.
I'd probably say
Yeah, just less than 10. And then right around 3. So next talk we need to have here. Is this going to be discrete or continuous? Let's take a vote. Who thinks discrete? Who thinks continuous?
oh yeah, it will never fully go away.
Well, that doesn't mean discrete or continuous. Discrete would mean like if there's only like this week there's this many, and then boom, all of a sudden the next week there's this many. Or do we think it's like a chemical treatment and then it's gradually happening? It's gradually happening. So we would connect these. This would be continuous. But Meredith makes a good point. Will we ever get rid of all the algae?
Doesn't Reed's Lake do this?
No, we will never get rid of all the algae because there's always going to be a third of whatever is left. Now, who can explain like what's happening with the numbers like just generally? Yeah, Sean.
Decay.
It's decaying, and then like a lot early, not a lot early. How would you describe like the line? Like
It's like going way down at first, but then it's like kind of balancing.
it looks like it's kind of even out. Here's why: a third of a big number is a big difference. A third of a little number is like not that much, right? So that's kind of just like when we did the percentages stuff. So it's going to decrease really quick and then approach 0 forever. Kind of the opposite when we look at an exponential growth, right? It'd be kind of chill and then all of a sudden take off. This one kind of takes off and then chills. Or it takes off toward the 0 is one way you could kind of say that. And this one's really steep because how much are we losing each time? We're losing 2/3 every week, right? So that's pretty steep. Yeah. Cool. Algae, baby. So after 2.5 weeks, where am I gonna put 2.5 into this?
Right in the middle.
The exponent, right? 2.5. And you slap that in your calculator, what'd you guys get? Something in the 30s? 15.84? Oh, I got 15.4 when I did it. And it's square yards, right? So after 2.5 weeks, we're left with 15.4 square yards, which doesn't seem like that much. Square yards for this algae bloom. Next up, we're going to look at insulin. So this is a medication that people with type 1 diabetes need to help regulate blood sugar. So if you have type 1 diabetes, your pancreas doesn't make insulin, you would die without it. Fun fact, you're going to learn some history here. Insulin for people with type 1 diabetes wasn't made until the 1920s, which is like relatively recent. Before that, not good for people.
About 100 years ago.
Fun fact, too, about insulin. First was made using horses.
I love horses.
They did this thing with their pancreas and extracted pure insulin. Now it's synthetic, so no more horse insulin, but that's how it originated. I read a book about it once. So, this insulin stays in the bloodstream, okay? And something's happening to it over time. You can see it in the image of the graph. What you need to know is you need to examine how much it's breaking down, what's happening over time, and we're going to work on writing the function for this with our partner. Here. So 1 through 4, who can tell me how much broke down in the first minute? How much? Zeph? 10. And so, as a fraction, that's 10 out of 100, or 1/10. Checking out first minute to second minute. Cam, thanks for raising your hand. How much did it go down by?
Well, wait, from the
First to second minute.
then it was like 10 and 9.
It went.
It wasn't exactly.
It went from 90 to 81.
So 9.
So it went down 9. And as a fraction, that's 9 out of how many were there?
90.
90, which is 1/10. So, what fraction remains each time it passes? Ivy?
9/10 of the previous.
Yeah, we know 9/10 remains because 1 minus the 1/10 equals the 9/10 that are left. All right? Maddie? So, next, you're going to try to get the next couple numbers, and then I want you, it doesn't even say here, but I want you on this page to write the function first for number 6. I'll write a little note on there for you. Write the function here.
In function notation.
All right, so you can see I finished up the table. I just kept multiplying things by 9/10. So the repeated multiplication every time, 9/10, gives me my decay factor, correct? So for my function, I'm going to go y equals, what comes next for my function? Elsa?
100 times 1/10.
So I got 100. Okay. So that's my starting amount. And then I need my growth or decay factor. Lily? 9/10. I'm losing a tenth. It leaves me with 9/10. And I'm going to go to the x power. Does it, oh, it says m minutes. We can't put an m there.
Oh, we just said T for
Either way, t for time. So now this says 10 minutes, so I'm going to slap that 10 in my function right there for m. So that means 100 times 9/10 to the 10th power is 34.87 micrograms. And that says after 10 minutes, there's 34.87 micrograms of insulin left. Now, is this one decreasing like as big of chunks
Not when you get.
as the algae? No, because why? What's the difference between the growth and decay factor, Ivy?
I was gonna say that.
Oh, what's
I
your,
got it.
what are you
I
going to say?
was gonna say like the graph doesn't like go down as like fast.
Yeah, why not?
Well, because the decaying factor. I mean, like it's most of the
it's most is left, right? Where when we had the algae bloom, 2/3 was gone. And this, we're only losing a 1/10 every time. So it makes sense. It's kind of not as extreme. So on this one, the graph was more like, where on the algae one, it was more like, right? More extreme because the 1/3 versus the 9/10.